Welcome everyone to Extreme Makeover Spark Edition. I'm Izzy Miller, a developer advocate at Hex.
And I'm Ariel Zahler Harnik, head of partnerships at Hex.
And today we're going to walk through a pretty classic Spark workflow, why it's so cool, why it is maybe a little bit outdated when you compare it to some of the more modern ways to run big data pipelines. And then we're going to show you how easy it is to convert it to a Snowpark workflow running on Hex. Sound good?
Sounds great.
Sweet. So before we jump into the actual technical demo, we'll give some background on Spark, what it is, why it's so great, and like we said, how it can be made even better. So Spark is kind of like an amazing candy land. It's a really powerful tool for running pipelines and data science workflows on data that's too big to fit on one machine, whether that machine is your laptop or even a giant server up in the cloud. If the data is too big to fit into memory or to be processed on one machine, Spark lets you really easily map that workflow, whatever it may be, across a cluster of however many machines you want. And it offers some data frame APIs that make it not that difficult to port existing standard Python or other language data science workflows into a distributed, super powerful Spark pipeline. But this is actually maybe a more realistic picture of what a Spark workflow looks like. The finished product may be the Candy Castle Wonderland, but Spark requires a lot of infrastructure management, a lot of keeping costs in mind, a lot of interesting little finicky, unique APIs and quirks that make it actually a little bit painful to run these processes sometimes. You have to be really familiar with niche parts of the Spark data frame API and other processing quirks. You actually have to spend a lot of your time doing infrastructure and cluster management and maintenance, which isn't what most data scientists enjoy spending their time doing. And often, as I did while building this demo, you get stuck on a licorice space and lose at least one turn, often many more turns, dealing with some strange problem that's difficult to Google and very difficult to debug in your cloud Spark cluster logs. So although the end result can be really powerful, there's all of this overhead that comes with the real meat of the data science, which is what all of us data scientists just want to do. And to give a really concrete example and ditch the probably overdone Candyland metaphor, this is what a data science workflow might look like on Snowflake using traditional Spark or other framework-based techniques. So your data starts in Snowflake, you do a bit of data prep in SQL, maybe in the Snowflake UI, save it to some temporary table, then drop over to a Jupyter notebook or another Python execution environment where you pull that data in and suck it out of Snowflake into your local environment, maybe do some feature engineering, maybe even load it into a Spark cluster, in which case the data goes somewhere else, do all of your training, however you like to do that. And then once you've done your training locally or in the cloud or wherever that may be, you have to figure out how to deploy that. And so now we're on our kind of third set of infrastructure considerations where you have to figure out the machine and the methodology and the containerization and all of that overhead of deploying your model, not to mention how you actually want to consume that model ultimately or surface it in an application. So kind of like I was just describing with Spark, but at an even bigger scale, when you're operating over all of these different contexts and tools, moving data around into different environments and contexts, there's a lot of overhead over that, like really core, true blue, training a model, deploying it, getting predictions from it, workflow that we all just want to spend our time on. So it really feels like there has to be a better way. Like this is not that inefficient of a workflow, and compared to the ones of yesterday or before big columnar databases existed, this is kind of mind-blowing. But when you start jumping between all these different contexts and moving so much data around, you start to think about what a better way might be.
And there is a better way. Snowflake Snowpark provides the benefit to do all of this. So your workflows that normally would span multiple tools, as Izzy just talked about, and sort of crawling through that Candyland world, can now all happen right within inside of Snowflake. Users can write familiar Python code, and Snowflake will actually handle that translation down to their engine. And if it can't be translated into SQL, then a user will write a UDF or a user-defined function, and that will run against the Python secure sandbox inside of Snowflake. So the benefits of this is that a user can actually write familiar Python and the data never leaves their warehouse, which means that it's both fast, but it's also extremely secure. So this is a little bit more of a simplified version than Izzy's Candyland way. So what does this look like in conjunction with Hex? Hex offers the best Snowflake integration to take advantage of the Snowpark API to support those data science workflows. And there are really three key areas that are beneficial here. The first is speed, the second is ease of use, and the third is model deployment. In terms of speed, there's a few different things that are beneficial here. The first is that the data transit time, that data doesn't actually have to leave Snowflake, it all stays inside of the warehouse. And also, Spark can actually run out of memory, and it takes a long time to get something like this set up. It takes a long time to actually maintain and manage this. And as a data scientist, you don't want to have to deal with the infrastructure management that comes with managing Spark. On the ease of use side, Hex supports a native integration both with Snowflake as well as with Snowpark, so it makes it super easy to write SQL or Python against your Snowflake warehouse. Users can easily run ad hoc queries, for feature engineering against their database versus having to dump that all into Spark. And then lastly, your model deployment is actually better. You're writing simple Python code right inside of one user interface. So instead of bringing the data to the model, we're actually bringing the model to the data. And today we'll talk a little bit about Snowpark ML and how you can make that possible. Alrighty, so let's jump into a live demo of migrating a Spark workload into Snowpark, all using Hex.
Excellent, let's get into it. For this demo, I will roleplay the Snowpark naive Spark user, and Ariel will be tutoring me through the conversion process. All right, so we're here in our Spark example notebook, and before I jump into the notebook itself, let's set up the problem a little bit. So today we're going to be working on kind of a classic problem case for machine learning tutorials, which is a credit card fraud classifier. So can we predict whether or not a credit card transaction was fraudulent or not? And this is a really common example tutorial project. If you look around, or depending on how you learn, you'll probably have stumbled upon it someday. And there's a bunch of data sets out there that are really small, manageable and nice and neat for you to pull into your local memory on your laptop and play around with, which of course kind of defeats the purpose of using Spark or even Snowflake or any kind of massive cloud scale data workflows. And so for this, we went and tracked down a data set that's actually appropriately sized. And this data set gives us information on users, cards, times and amounts and locations of transactions, as well as whether or not they were fraudulent. And it has actually tens and tens of millions of rows. It's a pretty large data set. So it's appropriate for using on cloud scale workflows to show a more realistic example of why you might use Spark or Snowpark or even Snowflake. So hopefully this provides a pretty realistic example rather than just a toy walkthrough. So to get started with this in Spark, we're actually running this notebook in a Google Colab instance. You could run it in local Jupyter or a hosted Jupyter lab or any notebook provider of your choice, and it would be about the same workflow. We're actually not going to dive super deep into all of the infrastructure management. You could set up a Amazon Elastic MapReduce or EMR cluster to run this on if you wanted to do a real production grade workflow here. But we'll quickly just breeze through the sort of overhead that I was talking about earlier without even dealing with all of the cloud infrastructure management. You can already see that we're having to download a bunch of raw packages and the open JDK development environment into our local context, installing a bunch of packages. We're going to be connecting directly to Snowflake here, actually, which is a better workflow than a lot of people sometimes do, where you run queries in Snowflake and download them as CSVs or some other format and then upload them directly into your notebook. So we're going to bring in the Snowflake connector Python package and wait for all that to install. And then we're going to go through a little bit of setup here to get everything working with Spark and configure our Spark session. Now, once we've got our Spark session set up, we'll bring in just a couple of other packages that we're going to use later, including the Snowflake connector package. And I actually, in a honest show of vulnerability, I attempted to get a Spark native Snowflake source working here for quite some time so that we could actually connect directly to Snowflake via Spark. And it was too difficult for my feeble little data scientist mind. And I found quite a lot of Stack Overflow questions with answers that were sort of similar to that, with people saying, actually, you should probably just abandon hope and do this a different way with raw, like command line Spark, which is a drag and not the kind of thing that a data scientist or analyst should have to deal with. You should be able to run your workflows in the like environment of your choice that you work best and most efficiently in. So belay that aside, we're going to quickly set up a connection to our Snowflake warehouse, and I have the password and environment variable here, but the other things aren't particularly private. So there you go. And then once we've set this up, we can run queries directly against our Snowflake warehouse in this Jupyter Notebook environment, which is awesome. And we're going to pull down just 1 million of these right now, because if we pulled down too many, then it would probably explode, like I was saying. So we'll pull down 1 million transactions to start. And when we actually run a real training run later, like we would crank this up to a sizable amount and read it right into Spark. Here's our data that we have all of these fields on, and then we're going to pass these into a Spark data frame so that we can actually run distributed queries and training on this. So we'll go through and manually create our schema, which takes a little bit of time to go and map everything to what kind of data type it is, a long type, a string type, a Boolean type. Once we have that set up though, we can pass our data frame from Snowflake into Spark, and then we get a Spark data frame. And Spark data frames operate a lot like normal data frames. They have a little bit of a customized API on top of them. So you run a .show instead of a .head, but they're very similar except for the fact that Spark knows how to slice and dice and distribute them across an entire cluster and how to run operations at scale on top of them, which is really, really, really powerful. So we're going to do some really light feature engineering here in our project, rename a couple of columns, then do a little bit of variable encoding for our Boolean variables and our categorical variables. We're going to do a little bit of timestamp massaging to get our various year, month, day, and time columns concatenated into one timestamp column that we can work with a lot easier. And then we're going to compute a column is at night to tell if something is at night or not. And we did a similar thing with is on the weekend. So just a little bit of light feature engineering, and this is all operating on our Spark data frame, and you can see we're using the Spark data frame APIs to do all of this rather than raw SQL or pandas syntax. Once we're done with that, we can run through this. We see that we've got 1,218 fraudulent transactions in our data set, so it's actually not a lot of fraud going on in our millions and millions of rows. Now that we have this Spark data frame that we'll call transactions with our transaction data, our sort of slightly massaged and engineered data frame, we can pass this through a Spark pipeline that will train a random forest classifier. And this is all pretty cut and dry, simple stuff. The goal here isn't to show some incredibly elaborate, mind-blowing, genre-defining model with incredible performance. It's more to show like really, really standard, classic, simple workflow, and then demo the conversion process. So here I'm importing all of the classic PySpark classification and evaluation tools. We'll define our input, output, and label variables, and then we'll pass these into, it's actually not a pipeline, it's just sort of manually assembled string of indexers, scalars, and then into our random forest classifier, which will train the data. And then once we get out our model from this distributed training, we'll do a really quick evaluation and print out our score. And it's actually pretty good given the amount of really, really minimal feature engineering that we did. It's nothing mind-blowing, but it's solid. We can print out our confusion matrix and see that not only is the score pretty solid, but we actually have a really, really low rate of false positives, which is the most important thing. So this is actually not a bad model. It wasn't the most time-consuming thing to create, but as you can see, there was a lot of boilerplate in there. And like I said, there was a lot of overhead and kind of running into memory limits or infrastructure management involved in working with the Spark cluster and running queries against it. So now we're going to look at how a better way to do this might look.
Awesome. Let's import this into Hex and convert it into Snowpark. Great. So Izzy, why don't you hit the top right import button to import your notebook?
Cool. I'll just find that IPyNB that I downloaded here and upload it to Hex.
Exactly.
All right. Well, this looks a lot like my old project. How should I get started converting this into a Hexy Snowpark project?
Yeah, Hex actually imports all of your code cells, and everything that you've actually done in your Spark notebook would work right away here. But we can do a couple things to actually simplify the workflow. So the first thing is that Hex comes with a bunch of pre-imported packages, so we don't actually need all of those import statements. You can go ahead and delete those cells.
Sweet. All of these?
Yep. The next thing is that Hex has secure data connections that you can see over here on the left side of your screen. So instead of actually typing out your credentials or possibly having to remember this every single time, we can use one of Hex's secure data connections. So simply just import the data connection that we need.
Okay.
And then if you click right next to the query button, there's a little drop down. There's a button to actually start a Snowpark session. And pressing that will import code and you'll be able to start a Snowpark session.
Well, cool. So if I run this, it's basically doing the same thing as this code cell above with all the manual configuration and credentials.
Exactly. So you can delete that cell.
Okay.
Awesome. Now, downstream in your notebook, you have a bunch of different Spark cells that are munging with data and actually doing a bunch of feature engineering. But some of this feature engineering is traditionally easier to do inside of SQL. Since Hex is polyglot and supports both SQL and Python, we can actually use Hex's SQL cells to translate this into SQL and store them as a Snowpark data frame that you can then use downstream. So why don't we delete a bunch of these cells and do that work in SQL instead?
Sweet. I'd way rather do this feature engineering work in SQL than with finicky Spark syntax. So I'm just going to delete all of these, and then I'll add a new SQL cell.
Exactly.
Cool. And I'll paste in some SQL here that does pretty much exactly the same feature engineering work as the previous steps.
And the benefit here is that Hex's SQL cells come with autocomplete, syntax highlighting, proper formatting, all the things that you're used to for a traditional SQL runner, but right inside of a notebook style interface.
Sweet. So we're going to pull in 2.5 million rows here. Is there anything I need to do to make sure this doesn't run out of memory in my notebook or anything?
Yeah. In the top right corner of the cell, you can see that it says data frame as the output. We can actually switch the output from a traditional pandas data frame to a Snowpark data frame, which will lazily evaluate your query, leave the result set in your warehouse, and only pull back a subset of results just so you can visualize what you're doing.
Cool. Well, that was super quick.
Awesome. Well, in code cell 3 here, you can actually see you're leveraging a bunch of PySpark. So if you wanted to keep this cell and actually run it using Snowpark, we can just simply tweak the import statements that you had above, and they will work directly with Snowpark. So why don't you paste those in?
Okay, here's my old import statements.
So everywhere that you see PySpark, you actually just want to convert it to Snowpark.
Okay, cool. And I guess I don't really need any of this anymore because we deleted all of that code. So I'm going to just delete those entirely. And I'll replace this with snowflake.snowpark. And so you're saying that if I run this, then I should be able to run the below code and it will work with my existing Spark code and the new Snowpark data frame?
Exactly.
Okay, I'll change this reference to data frame to match the Snowpark SQL query above, and then I'll run this cell.
Perfect. Nice. And just like that, you're able to run all of your PySpark code right inside of Hex with a simple translation into Snowpark.
Wow, that's so cool. So I can actually make my code easier to read and easier to write because I prefer SQL if I want, and keep it in the same Spark Snowpark format. I can even run SQL code and then run Spark code on top of the results of that SQL query. That's so cool. Okay, what's next?
All right, let's delete these two cells you have here in code cell 5 and code cell 6. And now we'll work on updating our random forest classifier model from PySpark into Snowpark ML.
Sweet, let's do it. What do I do here to convert this into a Snowpark compatible training pipeline?
So we're going to do a few things, but just take a step back and sort of like get an understanding of what we're doing. Instead of actually running this locally and possibly blowing up our kernel or pulling down the data and doing it in a local notebook, we're going to make some small changes to move this from PySpark to Snowpark, and we'll actually run this using the Snowpark ML library, which will run entirely in the cloud on Snowpark optimized hardware that auto-suspends and auto-scales. So the first thing to do is wherever you see PySpark, just switch it up to Snowpark.
Cool. I'll change these imports around. Okay, so I've updated those imports to pull from the Snowflake ML package instead of the PySpark ML package, but other than that, didn't change anything about the way these imports work. And I brought in a couple of extra packages I'll need later. I'm gonna replace this pipeline step with a neater pipeline that uses our Snowflake ML pipeline package. And then I'm gonna delete this later pipeline assembly step that we don't need anymore. I'm going to rename this field to match our earlier data frame SQL query, and then get everything ready to fit and to make a couple of test predictions. So I'm going to run this, and this is all going to run on that Snowflake optimized warehouse that Ariel was talking about. So it should be really quick. Wow, and I guess it's finished fitting and training and actually making some sample predictions already, which is really fast. I'm actually kind of used to my entire EMR Spark cluster taking longer to spin up than that, let alone actually fit a model and make some predictions. That's awesome.
Yeah, a Snowpark optimized warehouse is running on 16x the type of memory and 10x the cache of a traditional Snowflake warehouse. And the best part is that it's auto-suspending and auto-scaling based on your workloads.
Well, so I don't actually have to go remember to shut this down or tear it down when I'm done running this pipeline?
Exactly. You don't have to know any of that back-end machinery working that you were previously doing with Spark.
Awesome. Well, let's make sure that this model looks good. It fit really fast, but I guess we should make sure that it actually evaluates and gives us the results that we want. I deleted the earlier evaluation code. Is there anything special I need to do to add that evaluation back in?
You can add back in an accuracy score and confusion matrix in the same way that you would in any other workflow or notebook, right in a net new cell.
Cool. Well, I'm going to add that back in then, and I'll just calculate a quick accuracy score and get the rock awk, which I never know how to pronounce, and print out a quick confusion matrix so we can take a look at how our model is performing, make sure that it's up to snuff. Cool. And that looks awesome. So it fit and trained appropriately. Okay, amazing. So it looks like this model actually trained really fast and really well. I'm ready to use it. Earlier, we didn't really talk that much about deployment, but I mentioned that it can sometimes be kind of hard to figure out how to deploy the model once you've trained it. Like you're done with Spark and now you have to start dealing with Docker. And I actually don't really have a great idea of how the best way to deploy one of these models that I've built is without messing around with a bunch of other infrastructure and methods and libraries that I'm not super familiar with. Is there a way to use this same really nice, neat workflow for deployment also?
Yeah, for sure. It's actually really easy to do inside of Snowflake, and you can use all the same infrastructure and methods that we've been using today. Why don't we actually try using Snowflake's registry to actually register the model, and then you'll be able to access it downstream in any cell.
Cool. I'm on board. Let's try it out. So I'm going to create a new registry using the Snowflake model registry from the Snowflake ML package. We'll create a new registry using that Snowpark session that we created earlier. And then we're going to pass our model into that registry. We're going to upload it to a stage, which is basically just a temporary storage location for that model that Snowflake can access on. And then we'll run just a couple of pretty simple commands to upload our model to the registry along with some metadata about it. We can actually pass in the model version number, things like accuracy, so that later we can go back and see how our models have changed over time. So I'll pass that in, and then I'm gonna upload this model to the registry. And once that model is logged, which is what Snowflake calls uploading it to the registry, then we can register it as a UDF that can be called from any Snowflake or Snowpark query context. This means that you can actually call this model from any SQL query or from Snowpark code that you've deployed using whatever deployment mechanism you prefer, even a Hex notebook that's running on a schedule. So this actually looks like it's made it really, really, really easy to deploy my code in a way that I don't need to worry about APIs or containers or anything. I can actually just write SQL queries or Snowpark queries against my model and get back predictions really, really quick. Cool. Wow. That was really quick to deploy, and I can see that it succeeded. But what does deployment actually mean here? Like, I know that it's gone somewhere, but how do I access it? How do I use it to make predictions?
Deploying a model with Snowflake means that you can access it anywhere you can access your Snowflake data. So for example, you could actually open up a net new Hex project and actually run this model on some data with just a couple lines of code, instead of going through all the complex training and modeling that we just done before.
Cool. Okay, I'm going to do that. I'll open a new Hex project and try it out. I guess I'll paste in that SQL query from before so we have our data all in the right shape, and maybe I'll just bring in a couple of rows for testing this prediction. I don't need all of those packages from before, but I guess I do need the Snowpark function so that I can call this UDF. So I'll import that really quickly. And then I'll just run a simple Snowpark select statement and call this UDF to get back some predictions. And yeah, sweet. This totally works. I just ran from a totally new environment and new context a query that used this model that we deployed and got back predictions in just a second.
And Hex's integration with Snowpark actually takes it one step further. All of your Snowpark data frames can work in any downstream cell. So for example, if we wanted to, we could actually chart the result of this data frame.
Wow, and I can see how I could use this to build like a complete interactive report using Hex based on the Snowflake trained and deployed model, and then publish this Hex report out for anyone to access. That's so cool.
Exactly. Super easy to publish, super easy to share, and really easy to build those interactive reports.
Thank you so much, Ariel. This is basically functionally the exact same workflow I had before. I mean, it's giving me the same predictions and the model is the same, but the entire pipeline to train it was way easier to set up, was way faster. And from what you said, it sounds like it's running on much more modern infrastructure that will turn itself off and not waste money, and takes like a second to spin up instead of 15 minutes. And the data is actually never leaving the secure Snowflake storage. So I'm really, really happy about this. Thank you so much.
And if you're interested in trialing Hex for 90 days free and trying out moving your PySpark workloads into Snowpark, scan our QR code here and you'll get a promotional deal for an extended trial. We'll also drop the link in the resources section of today's video. Thanks so much.